So I talked about a normal eye. That's what would happen with a normal eye. But not all eyes are normal, certainly not mine. And it's very easy for an eye to be out of shape, not to have the right shape that it should have, to produce an image of an object that is at infinity, to produce it right on the retina. That's a pretty common problem. So what ends up happening is that for whatever reason, it could be a reason involved with the shape of the cornea, or it could be because your eyeball is just too elongated, for example. You might end up with a situation where an object at infinity, so you have light rays coming from infinity, so they're coming parallel, and what I have here is the eye, of course, and the crystalline lens in front. Those light rays get focused here, and for a normal eye, that coincides with the location of the retina. So that's good. That's a normal eye. But as I said, for different reasons, you might end up with an eye where the location of the retina is behind the place where the image of an object at infinity is formed. So if your retina is here instead of there, is this with a Y? You see what it looks like? That looks okay, right? So a myopic eye has the retina behind the place where the images from infinity are formed. And the other possibility is that your retina might be actually in front of the place where images of objects at infinity form. So this is a hyperopic eye. So how would you correct for the myopic eye? What you want is to be able to move this place where the light rays intersect, move it back on the retina. Push it to the left. Right? Light rays coming from infinity. So a myopic person, as you can see, cannot see objects that are far away, because the image of those objects forms in front of the retina. So if I take off my glasses, I see perfectly fine here. I can accommodate, but at some point I'm not able to accommodate anymore. And perfectly relaxed eyes, when I look at an object far away, the image is being formed actually in front of my retina. So it looks blurred. So how can I move that image back? Think about what you would need to do, what treatment you should do to these light rays. Focus here, but the focus is a little looser. Because for a myopic eye, it seems you have too much converging power. That's another way to look at it, right? If you were to accommodate, worse. You see that? Because if this lens were to decrease its focus, which is what happens when you squeeze those muscles in your eye, this point will move this way, because you will be reducing the focal length. Okay? So for myopic eye, accommodation only makes things worse. Relaxed eye does not get you the image at the place where it should be. How do I push that back? So as I said, this is too strong. You want to weaken somehow the converging power of this lens. You want to weaken it. What can you do? Diverging lens. If you put a diverging lens in front, trying to get it exactly on the retina. That's good enough. So if you put a diverging lens in front of your eyes, and that's what I have here, tell that it's a diverging lens because the center of the lens is thinner than the edges. Center thinner than the edges. So then the light rays are no longer going to be parallel. When they hit this lens, the light rays are no longer parallel. They're already diverging a little bit. If they're already diverging, right, then when this lens tries to converge them, they're going to converge at a point that is further back, which is exactly what you want. You want to move the point where they converge back on the retina. Okay? So any person with myopia would need glasses or or contact lenses that are divergent. Another problem that people have is, as I said, hyperopia. So in that case, your eye, the length is a little shorter than usual, or maybe the converging power of your lens is not strong enough. So in any case, the image is formed behind the retina. So what you want to do is make these light rays converge at a point that is closer. That means you want to reduce the focal length of the combination of lenses that you have. If it's just a crystalline, that's not good enough. You need something else to make these light rays converge more strongly. So that tells you that for a person with hyperopia, you want glasses that are converging lenses, that are thicker in the middle, thinner on the edges. If you do that, then the combination of the two lenses has more power than just one lens, meaning that the focal length gets shortened from the equation that we saw before, and now they actually get focused at the place where you want them. All right? So those are the two most common problems, and how or what kind of lens you will use to correct for those problems.